So good morning. I'm Patrick Mechin, founder of Techway. Techway is a French company. We've been acting for 20 years, and we are mainly active in the defense sector. So we are an FPGA company. We are specializing ourselves in the data acquisition and equipment for high-speed data acquisition. So today I'm going to share with you some of the things we're doing to widespread the technology over not only over the defense market, but also over the industrial market. So on how we are using the FMC standard, the VITA 57 standard, to provide high-end solution to the industrial market and to the defense market. Oops. Okay, so to start with, I wanted to share with you what we're doing with optics. It seems that today everyone is going to speak about high-speed communication, and apparently being able to implement high-speed communication links is a big topic for our industry and for, I would say, most of us here. So to address this issue at Techway, we've been designing optical FMCs, especially with a partnership with our friends from Samtex. And we have a full range of FMC that are featuring the latest Firefly technology from Samtec, especially the new 25 or 28 gig to address the high-speed and high bandwidth communication issues that have been raised by my colleague here. So we are delivering that technology on FMC to address the defense market, but not only the defense markets, as I'm going to show you. The other part of our offer is a full range of PCIe Express boards, so featuring the FMC connector. The goal of our product offer, again, is to allow other industry than defense to benefit from the VITA technology and to all the technology which is done by suppliers who are providing VPX system. So for sure, VPX is the dominating market segment in our industry, but there are a lot of other options, a lot of other market segments in defense and also in the industry that could benefit from all the optics and high-speed communication, and of course the new FPGA capabilities, but cannot really afford paying the high cost of VPX. And these are the market segment we are addressing with these boards, helping customers to take benefit from the optics, for instance, and the new technology. This is, by the way, our new baby. So it's a way to illustrate how the 28 gig optical capabilities, which are currently available through Samtex, together with the FMC technology and the PCI Express technology, will allow us to deliver a solution on a cheaper platform, the VPX platform. By the way, one of the big trends also today, apart of the high-speed communication, is the new system-on-chip capabilities that FPGA vendors are proposing. This is a very heavy trend in the FPGA marketplace, which is very well illustrated by the merge of companies like Intel and Altera and AMD and Xilinx, which shows the direction this market is taking. And system-on-chip capabilities is today very popular for developers, and we see, at least at Techway, that most of the program, people are looking for system-on-chip capabilities. Anyway, we are offering system-on-chip options on our boards to fulfill the demand from the marketplace. So why the benefit of using, sort of a PCI Express base, of using, I would say, the VITA technology on PCI Express is, as I already mentioned, it's a cost-effective when you compare it to VPX form factor, and there are a lot of applications, including in the defense, where VPX is not required. I mean, I'm thinking about ground-based system. I'm thinking of naval application. We also have application, all the test equipment application. They need the technology. They need the high bandwidth. They need the real-time capabilities of the FPGAs. But it stays on ground. So they are looking for possibility to implement all these new features on the server-based type of configuration. And that's where we're going to fit in, at least opening the capabilities to these people. So you understand that thanks to the FMC, the product is versatile. You can use it with digital FMCs like the optical ones I've shown you, but you can also use the most advanced analog to digital and digital to analog converter, which is needed by the radar or the electronic warfare industry. Of course, using COTS, as you know, helps to speed up the integration processes compared to in-house design. So this is part of the effort. And of course, despite the fact that the product is VPX-based, it has been designed for defense, and it comes with long-term life cycle capabilities. I wanted to share with you a list of domains where we are already selling that technology, just to show it that a lot of it goes in defense. Thanks to the new 28 gig platform with associated FPGA technology and optical, we have a platform on which a customer could use the latest analog to digital and digital converter, the one who goes above multiple gig and required high-speed GESD interfaces, and as well as the 100 gig transmission, digital transmission for more telecom-oriented application. And when you think of the digital part, most of the protocol today have been upgraded in their specification to support above 10 gig communication rates. This is almost obvious for protocol, well-known protocol like Ethernet. Of course, that's for telecom, but in avionics, there is a protocol named ARANC 818, on which we have specialized at Techway, which does the same job, except that instead of moving data, it moves the video data for airplanes. There is the ODI or Ethernet or serial FPDP protocol in use in the test and measurement industry, and as well as in defense. I've listed two of them as serial FPDP and ODI, but all these protocols are today on a path of operating at speed above 10, obviously, and even above 25, or even merging links to create 100 gig communication links. Few examples, and it's interesting just to materialize the idea is you have here two two examples from our customers who are using our FMCs and VITA technology on PCI Express. One on the right hand of the screen is in the telecom industry. He needs to analyze information on optics. These guys, they are in the 5G industry, and they have to deal with signals, with optical communication links that are going above 25 gigs. And thanks to the system-on-chip capabilities of the platform, they have been able to create very small standalone equipment which are operating at very high speed, in that case, above 25 gigs. On the left hand, you see a more traditional implementation of boards into a workstation. But again here, the customer who is making GNSS simulator have been able to take benefit of the platform in terms of cost. He was able to implement a very advanced analog to digital interface of his own and be able to deliver to the market, to his market. This is a GPS marketplace, a standalone system that they are selling all over the planet. So these are just two examples of how we could have the VITA 57 technology being widespread on other domains thanks to the cost-effective platform. So summary, we are helping the industry to make benefit of high-speed COM and FPGAs thanks to the VITA 57 definition. And today, the technology we are promoting, as many of us here, is the 28 gig on optical, which allow many applications to cope with the technology and the market challenges. Thank you for your very attention and open to questions.